All right, so we're moving on now into the crude oil industry. So something that we've seen before. All right, so let's jump in. Now, we remember with industries, what we're trying to look at in chemistry unit 2 is, all right, we have to know what industry is we're looking at, right? That's the first thing. We have to understand now what is the source. What are our reactions that we use in the industry, and what is our ultimate goal? So remember those three things, right? We need to know the source for the industry, where we get the something from. We need to know the reactions, right? So what are we going to do to that source in order to get our product, which is ultimately what we want, right? Then after we look at all that for the industry now, then we look at the importance, the applications, and their impact on the environment. We're literally doing that for every single industry. All right. So crude oil industry now. So crude oil is a complex mixture of hydrocarbons and other substances found in underground reservoirs, right? Extracting it from the earth involves several steps, right? So we need exploration, drilling, rotary drilling, right? And well casting and cementing. Right? So these are different processes, right? So exploration now, right? So these are where the geophysicists will come in contact now, right? So the geologists, right? The geographers, right, and the geophysicists, right? So the process begins with geological and geophysical studies to identify potential oil reserves, right? So we use things like general seismic surveys, sonar, and different types of waves in order to figure out where is most likely containing some crude oil, right? Then we drill. So once a suitable location is identified, drilling rigs are used to bore deep into the earth to reach oil reservoirs, and this can be done onshore or offshore. The drilling process involves now rotary drilling, right, where a rotating drill bit is used to bore through rock layers, right? Drilling mud, right, a mixture of water, clay, and chemicals, is pumped down to cool the drill bit, right? So remember, we're continuously rotating and drilling into rock, right? So the amount of friction that would create a large amount of energy, heat energy, right? So we just pump drilling mud, right, which is water, clay, and some chemicals, right, to cool the bit, right, removing cuttings and maintaining the pressure in the area as well, right? So well casting and cementing now, as drilling progresses, metal castings are inserted into the wall of the hole to stabilize the borehole to prevent it from collapsing on itself, right? The casing, right, or the casing rather, is cemented in place to isolate different geological layers and prevent fluid migration. All right. So we drill a hole and then we fortify the hole with casting some walls and cementing it, right, to make sure that the hole remains open. All right. So that's fine. That should be fine. So we're good. So really and truly we drill, baby, drill. All right. So the production. After reaching the oil reserve, various methods are used to extract the oil. So the primary recovery, secondary recovery, and enhanced oil recovery. Right. So primary recovery now. So this involves using the natural pressure of the reservoir to bring the oil to the surface. Right. It includes installation of pumps to help with extraction. So pump it out. Right. So looking at that. Or secondary recovery, when natural pressure decreases, techniques like water injection or gas injection are used to maintain pressure and improve oil flow, right? So remember, liquids move from higher pressure to lower pressure. So what we're trying to do is increase the pressure in one area to allow the fluid to flow into that into that area of low pressure, and then we continue, right? So we're trying to maintain a pressure gradient to cause the fluid to move up. Alright, for persons who do unit 2 biology, it's the same thing that the heart does. The heart has lower pressure, fluid flowing from higher pressure to lower pressure. So we want to create a pressure gradient in the hole so that the fluid moves from the bottom of the hole to the top. Alright? And we have enhanced oil recovery now. Advanced methods like steam injection and carbon dioxide injection or chemical flooding are used to extract additional oil from depleted reservoirs, right? So after we've done the entire reservoir now, we can use EORs, right? Or EOR itself to now extract anything, any sliver of oil left in the reservoir, alright? And it's pumped all the way to trucks or ships, and then the crude oil will find its way to the industrial plants, right? Now, separating the components, we have to use fractional distillation, right? So we have atmospheric distillation and vacuum distillation here, right? For fractional. So crude oil is heated to around 350 to 400 degrees Celsius and fed into the distillation column. The components with the lower boiling points vaporize and rise through the column where they are collected at different levels, and this process separates out, well, this process really and truly separates the crude oil into fractions like naphtha, kerosene, diesel, and heavy oil. So these things we have seen before. Nobody can tell me so them not see it before. Alright? Vacuum distillation now, to separate heavier fractions now, a vacuum distillation column is used, allowing distillation at lower temperatures. This avoids thermal cracking and degradation of the heavier fractions. So if we want to get heavier fractions without breaking them up or cracking them into smaller fractions, we use vacuum distillation. Alright, so here's a fractionating column. I'm pretty sure this is very familiar. Alright, so feed the crude oil in and we heat at the bottom. Alright, so the ones with the smaller boiling points would vaporize and move up. Alrighty, so you guys should be able to look at this diagram. Also, this is a diagram that you must be able to reproduce. Right, obviously when you're going online, you find a diagram that is true to the concept, and try to find like the diagram that's easiest to draw and try to memorize how to draw that one. Alright, so one that you find easier to draw. So when we pump the crude oil in, we heat it and go through fractional distillation there. And you guys should know the principles of fractional distillation, but I won't haunt you with the formation of a zeotrope right now. Alright, a zeotrope. But yes, so the lighter, more volatile molecules are at the top, and the larger, less volatile, right, molecules are at the bottom. Any questions or concerns before we move on? Doesn't seem like there are any. Alright, so this poorly depicted table, right, is my attempt of displaying or portraying the columns to use, the fractions, right? So gases, general gases. You have light naphtha, heavy naphtha, kerosene, light gas oil, heavy gas oil, and the residuum, right? Or bitumen, and those things are found in those layers, right? So the number of carbons in the carbon chain is there as well, the boiling points, right, and general percentage that is found within those layers there. Alright. There should be some information that I should provide to you guys, but I'll see if I can find it when the class is over. Alright. So you guys just need to look at that. So try to find the length of the carbon chains for the products at each fraction. Alright, I should have something that I could send in the WhatsApp group. So you guys need to memorize the table as well. You need to know the boiling point, number of carbons for each of boiling point, and number of carbons for each of the fractions, right? So bitumen is usually what? 10 carbons or around 15, 19 carbons thereabout. So you need to like know the different carbon lengths, alright? Well, that's not bitumen actually. But you guys need to know the different ones. So I'm going to see if I can send you guys a table on that. Alright, but really and truly, fractionating column, fractional distillation, stuff like that, that's the process that we use now to separate the crude oil into different fractions. And we know the principle that the lower sections of the column will have bigger molecules, right, that are heavier, have a higher boiling point, and less volatile, while at the top we have smaller molecules that are more volatile, right, ignite easily, and have low boiling point. Right, so you guys need to know those differences. You need to know them. All right, it's not an ask or an if or a but. So the conversion process is now cracking. Right, so cracking itself, we know that large hydrocarbon molecules are broken down into smaller ones, right, more valuable ones. This includes thermal cracking, catalytic cracking, right, and also what we call hydrocracking and coking. Right, hydrocracking is hydrogen is added to a large hydrocarbon and remove impurities like sulfur. So hydrocracking basically, what it does is purify the hydrocarbon really. Right, so it attaches itself to more reactive elements that are not in hydrocarbon, and it takes it away. Right, So we're looking at that. So it breaks the larger hydrocarbons, and while it's breaking it, it removes the impurities, the reactive impurities. And coking, the process, right? This process converts heavy fractions into lighter hydrocarbons and coke, right? A solid carbon byproduct, coke. You guys remember what coke is, or what coke is used for? The reason why we use coking sometimes, other than thermal and catalytic cracking, why would we want coke as a byproduct? Hello? Any ideas as to what coke is? Do you guys remember where coke is used? Coke. I mean, the purification of iron uses coke to lower the melting point of the substance of the solution, or the Let me just leave it as a substance, right? So coke is used in iron purification. All right, that's there. I almost had a fit a while ago. All right, so let's look at this chemistry of thermal cracking. Right, so this is now like a way more complex than what you saw in module one, right? Where we have homolysis, right? There, the homolytic bond cleavage in initiation. Then we have the propagation, right? And then we now have the termination down there. So thermal cracking is free radical in nature, right? So we end up now, right? So after we do all of these different things, right, we end up with the radical combination and disproportionation, right? And isomerization reactions can occur as well, right? Beta scissoring or beta scission, right, is actually what we use to create a faster form of a faster form of the product, right? Rather than if we go through everything with radical combination, right? But we're just looking at this. We're just looking at this. So you don't need to know this process. I'm just looking at the fact that thermal cracking is what we tend to use, right? And I just give you an overview of what thermal cracking is. Alrighty. So we have that there. So the cracking processes now, we have catalytic on one side, on the right side, and thermal on the left side, right? And I gave you guys information already. So if you don't remember the information, I suggest that you go to module 1 and you get the information, alright? Lovely. Alright? So how fun it would be if your past paper had cracking in module 1 and it come back to ask you about crude oil industry in module 3. How lovely would it be? Alright? So we have this there. Shouldn't be much of a problem. We'll move on now. Treating and purification. So after all that cracking business, we don't just leave it as it is. We have hydrotreating. So impurities like sulfur, nitrogen, and oxygen are removed from the hydrocarbons using hydrogen and catalysts. And we have desulfurization. This process focuses on removing sulfur compounds, right, to reduce emissions when fuels are burned, right? So sulfur is present in the fuels that we produce, right? But we don't want the sulfur to be combusted. Why don't we want the sulfur to be combusted and released into the atmosphere as sulfates? Why not? What happens when sulfates are released into the atmosphere? Ashanti knows what's going on, but Ashanti don't want to answer. Daniel knows what's going on as well, but Daniel doesn't want to answer. Shania and Astina know exactly what what the answer is. Alright, and they don't want to answer. I'm not sure why. If sulfates and sulfides go into the air, what's gonna happen? It's gonna react with water in the atmosphere. It's gonna produce sulfuric acid that will fall as acid rain. Lovely, right? So we have that there. So looking at the hydrogen injector that we use for hydrotreating, right? Here as an example. So we try to treat and purify the gases now to remove the impurities. So when we burn the hydrocarbon, we don't burn it with the impurities that will add to our emissions, right? Okay. Components of the crude oil and their uses as fuel. So liquefied petroleum gases, LPGs, right? Mainly propane and butane is the composition here, and it's used as cooking, gas pro, hashtag gas pro, used as auto gas in vehicles, and it is also used in industrial applications as a propellant in aerosol sprays. All right, so looking at that. Naphtha, which is a light fraction consisting of hydrocarbons with relatively low boiling points. Naphtha is a key raw material in the petrochemical industry. It's used as feedstock for steam cracking. All right, and can be used to produce gasoline or solvents, right, or other solvents. So it's naphtha that we use in steam cracking, to produce the hydrogen. Right, so it's one of the things that we use in hydrogen production. Gasoline now, right? So a blend of hydrocarbons with boiling points from 30 to 200 degrees Celsius, right? So we know that gasoline is used in cars, motorcycles, trucks, all sorts of stuff, right? Used as fuels. Right? It is blended with various additives to improve performance and reduce emissions as well. All right. So when one company sell gas and the other company sell gas and a gas alone, they're selling their own blend of gas, right, with different types of additives in it to improve the performance, right, of the gasoline itself, right? When you combust it, how much energy do you get, right? If you guys want to do EVs, right? So electric vehicle technology, and look at how it translates to regular gasoline fueled vehicles. You could look at different brands of gasoline and how far does it take you, right? In a car. So for example, you could use car A, right? And look at how many kilometers one gas take you in car A than the other brand of gas. You could look at stuff like that, but there are different mixtures that different companies will sell. All right. So looking at that, kerosene, right, is is a composed of hydrocarbons with boiling points ranging from 150 to 275 degrees Celsius, right? 75 to 80 are on there, right? Kerosene is used as jet fuel for aircrafts, used as heating fuel and in lamps, right? It is also used as a solvent in industrial applications, right? So it is a non-polar solvent. So not everything will dissolve in water, obviously. We have to use a non-polar solvent for non-polar solutes. All right, so kerosene and toluene and stuff like that are used for it. Diesel now. So diesel is hydrocarbons ranging from 200 to 350 degrees Celsius for its boiling point. And it's used in compression ignition engines commonly found in trucks and buses, ships, trains, and some cars still use diesel, right? And it's used for heating and power generation. Heavy fuel oil now. These are the heavier hydrocarbons now used in high octane hydrocarbons, right? Used in large ships, power plants, and industrial boilers, right? So these are things that would use now in, let's say, the sulfuric acid industry, the aluminium industry, and stuff like that. These are things that we burn to produce the energy, all right? And then the lubricant oils now, right? So obviously they're going to be using as lubricants, lubricating oils, right? So they're used as greases, right, that we can use to grease and reduce friction on machinery. All right, of a very high viscosity. And then we have bitumen or asphalt, right? So it's the heaviest fraction, right, with very high boiling points and high viscosity, right? So we now use those for roads, for construction, roofing materials, right, stuff like that, right? So we use the bitumen or asphalt for that. Alrighty, so that's really and truly all different fractions there, right? And then we have to move on to the petrochemical industry, which is also in this topic of the crude oil industry. Alright, so really and truly the crude oil industry is the petrochemical industry, but what we looked at a while ago was just the extraction, the fractionating tower, right? Distillation, and then some uses of each of the fractions. Alrighty. Now for the petrochemical industry now. So these are the industries that rely on the hydrocarbons from crude oil as a feedstock. So they use them as sources now. So we separated and produced these hydrocarbons now, right? Now these will be used in a wide range of chemicals and materials, right? For example, methanol, right? Simplest alcohol is used or is derived from natural gas, right? Or from other hydrocarbons. It's used as a solvent, it's used as antifreeze, and used to produce formaldehyde and acetic acid. Ethylene glycol is used in the production of polyesters and antifreeze as well. Polyvinyl chloride as well, right, is used in vinyl flooring, in pipes, and for construction materials, right? And its aromatics is used as well. So aromatics are used to create a variety of chemicals including plastics, adhesives, and synthetic rubbers. Ethylene and propylene, right, which is basically ethene and propene, right? These are now used. It's derived from naphtha through steam cracking, and it's generally used as fuels or to produce polyethylene, polypropylene plastics, right? Benzene, toluene, and xylene, right, are actually used for the production of stuff like polystyrene, different phenols, right, polyurethane, right, as well as the manufacture of synthetic fibers and resins, right. So these are the uses, right, of the different sections of the crude oil that we separate, right. So these are just some, right? What I placed here were things that you won't think about naturally, right? Naturally, no persons think about the fact that crude oil things are used in the fashion industry, right? So many other things that you use, many of the hair products and stuff like that, derive from these different things, right? Petroleum jelly. It's not called petroleum jelly just for fun, right? So these things are used in aerosols. They're used in generally the fashion industry. They're used in production of clothes, right? So polyesters, right? Clothes and linens and stuff like that are made out of polyesters. So many of these things come from crude oil, all right? And some persons find it hard to believe that their shirt can literally come from crude oil, but it is. Yes, it is. Right? Or it is a byproduct of the crude oil industry, the petrochemical industry. Right? Environmental impacts now. So we should know the environmental impacts of crude oil, right? Of the crude oil industry, right? So the deforestation and habitat destruction, right? So we're going to be clearing land to drill, right? So we know that will disrupt local ecosystems and displace wildlife, right? Soil degradation, erosion. So many, you see, all of this that we spoke about, it's the same thing for the aluminum industry. So the okay thing about these topics is that the impact on environment is usually or largely the same, right? So it's the same thing going to be happening here, right? Soil degradation, right? Not only are we removing trees that will result in soil erosion, but drilling now, right? Drilling sites and pipelines can cause soil disturbances and erosion, leading to sedimentation in rivers and streams. We know we'll have water contamination once the fluids and chemicals used in the extraction process, right, contaminate groundwater supplies. Remember that we're drilling, right? So it's going to contaminate groundwater supplies if there are any near. And then we have air pollution as well. So when we burn all these petrochemicals, now we're releasing the gases and particulates into the air that will affect the air quality, right? That's why the air in Kingston is so trash compared to other parishes in the island, and as it relates to other Caribbean islands as well. The ones that don't have a large industry tend to have better air quality than the others, right? Because once you have large industry, the air quality will be decreasing, posing health risks of bronchitis and lung cancer, and these things can now develop, right, due to the exploitation, right, of drilling. All right, so other things as well, oil spills. So not only do we collect the oil, but the oil has to be transported in some way, and the major way in which oil is transported is across our oceans. All right. So we're looking at stuff like oil spills that may affect the environment, the marine environment, right? So not marine and, well, not really freshwater, right, environments, but marine environments and marine shorelines and these different ecosystems, right? Gas flaring as well. In many oil production sites, excess natural gas is flared or burned off, releasing carbon dioxide and pollutants, right? So the excess gas which is produced is just literally burned on site. Methane emissions. Now, methane, a potent greenhouse gas, can be released from oil wells, pipelines, and storage tanks, contributing to climate change as well. Alrighty. So looking at stuff like that. So the environmental impact of refining and processing now, right? I know it's a lot of things, but module 3 of all AKIP subjects is a bag of chatting. Alright? So you just have to bear with me as we go through the information, right? So air pollution, right? So we're looking at the releasing of sulfur dioxide, nitrogen oxides, and other volatile organic compounds, or what we call VOCs. You see on the paper, when you say VOC, don't come and tell me that this is a vanadium, oxygen, and carbon complex. It is not, right? I had to deal with this last year. It is not vanadium we're talking about. It's not the element. We're just talking about volatile organic compounds. And we know what volatility means, right? They're easily evaporatable or easily vaporized, meaning that they're present naturally in the air and can cause respiratory issues and contribute to acid rain and smog, right? These terms are used on papers, you know. All right. So water pollution as well, that should be self-explanatory, and solid waste as well. So byproducts, for example, petroleum coke and other byproducts, which must be managed to avoid environmental harm. So if you refine these different crude oil substituents, right, you can produce solid waste. And if it is mismanaged now, then that can actually really bring forth land pollution, soil pollution, or what we call solid waste pollution. All right. So looking at that, environmental impact of the consumption of these things now, right? So carbon dioxide emission, right? So remember, we're using gasoline, right? So gasoline, kerosene, propane, no, not propane, propane, right? These things that we use as fuels. When we combust hydrocarbons, we can produce carbon dioxide, which is contributing to global warming, right? We also can produce carbon monoxide, sulfur dioxide, nitrogen dioxide, other particles, right, that will contribute to air pollution and public health risks, right? And also, we use the petrochemical industry to produce plastics. So, when we now not reuse and reduce, reuse, and recycle, we end up with plastic waste in the ocean and landfills, impacting wildlife and ecosystems, right? So looking at stuff like that. So that is generally the environmental impact of consumption there. So that was really and truly the brief overview of the petrochemical industry there.